Let's consider the following continuous probability distribution. Here x follows a uniform distribution from 1 to 8. We can see that graphed over here. And we can ask this question then, what is the probability that is shaded? What amount of area is shaded under that curve? Well, that will represent the values that start at 2 and then go up until 5. We can determine the height of the following continuous uniform probability distribution. Remember, since it is a probability distribution, area of this rectangle should be equal to 1. And the way we will calculate this is the length of our rectangle times the height. So we can look and see what's the length of the entire rectangle that we have. The length must be 8 minus 1, which is equal to 7. So I can substitute this in. 7 times the height must be equal to 1. And if you solve this for the height, then the height must be 1/7. That represents here. The height of the rectangle is 1/7. That is the constant line. It is also our probability density function, f of x. And that would work out too if we use the formula. F of x is equal to 1 over b minus a, which is 1 over 8 minus 1, which is 1/7. So that was a specific case, but in general, since we know the area of a rectangle, we can find a formula for all of these different probabilities. Okay, we know that the probability will be associated with the area. The area is always the length times the height. So what is the length? We could look in between here and here. The length of this will be given as whatever value k you pick, and you subtract it off of a. So the length is k minus a. The height is always given as 1 over b minus a. And you can think about this as being over 1. So if you wanted to find the probability that x is less than k, you would take k minus a and divide it by b minus a. Length times height. And we can just keep going. The length times the height. So if we're looking for the probability that x is greater than k, we're now looking for this length. That length is b minus k. Again, it gets multiplied by the height, which is 1 over b minus a. And if you multiply these together, if you're looking for the probability that x is greater than k, you take b minus k and divide it by b minus a. And then lastly, we can find the length of a side in between two values. Okay? So again, length times height. The length here is given as k2 minus k1. That's the length, k2 minus k1. Again, if you want to think about it over 1, that's fine. The height is always given as 1 over b minus a. So if you're looking for the probability in between two x values, you take k1 minus k2, k2 minus k1 divided by b minus a. So let's go back to example 2 that we had worked with. We had said the shaded area there was the probability that x was less than or equal, that x went in between 2 and 5. Okay. So the probability in between, I'll just mark this one up. So we'll say k1 is 2 and k2 is 5. We saw that the height of this rectangle on the above example was 1/7. So if we were determining the area in between this, we would take 5 minus 2 and divide that by b minus a, which in our case was 8 minus 1. So this becomes 3 over 7, which is the same thing as 3 times 1/7.